Okay, let us talk about momentum in two dimensions. Momentum is a vector, so this means the direction is important. So what we have here, let's take an example. I've taught two ice skaters collide. Right. I'm going to use Torvill and Dean, who are a pair of famous ice dancers. So Torvill equals 70 kg at 15 meters per second east, and Dean equals 60 kg 10 meters per second south. If they stick together, if they grab each other, and move off together, well, some type of dance, move off together, what is their final velocity? Yeah, final. Okay, so this is cool. So this is, believe it or not, this is going to be a conservation of momentum problem. When you're dealing with momentum in 2D though, you have to add momentum together. So let's start with Torvill. Torvill, P initial, equals mass times velocity, so it's equal to 70 kg times 15 meters per second equals 1015 kg meters per second. Okay, that's cool. P Torvill, P momentum of Dean is equal to, and that's going to be important, east. P momentum of Dean is going to equal 60 kgs times 10 meters per second equals 600 kgs meters per second south. And so we're going to assume that we've got these two stages coming in, they hit and they move off together. So coming in, bang. So what we can do is, how do we do this? From conservation of momentum, P final is equal to P initial. But these are vectors, these have directions, so we're going to have to add these using vector mathematics. So P initial equal, well, I put in Torvill, P Torvill, it's 1050 kg, and then I put in Dean, 600. So these are two vectors, so I add them together the traditional way. So I add them together, I draw in the resultant. How big's the resultant? Well, the size, P initial, the size is going to equal the root of 1050 squared plus 600 . So calculate time, done. 50 squared plus 600 squared equals, take the root, so we're just using Pythagoras' theorem, 600 squared, bump, take the root, is 1209 kgs per meter squared, kgs per meter. So that is going to be, this here is going to be the size. P initial equals 1,000. Okay, and the other thing that we need to know is the direction. And again, we're just going to use vector mathematics exactly as we did before. We've been using tan function, so katoa. Well, I'm going to use the opposite and the adjacent. I'm going to find out that angle there, because they start there, so I'm going to find the angle from where they start. So, that's going to be tan theta, equals opposite over adjacent, theta equals tan inverse, opposite over adjacent equals tan inverse 600 divided by 1050 equals, well, it's what they invented calculators for. Tan inverse 600 divided by 1 equals 29.74 degrees. 29.74 degrees south of east. So I look at the east, it's going south of there. So the P initial, we've added it up, so P initial equals 1,209 kilogram meters per second at an angle of 29.74 degrees south of east. Okay, the next question is, what's their final momentum going to be? This is the initial momentum. So we have our two skaters and they collide, and our initial momentum actually looks like this. They come this, our initial momentum actually carries on just like that, and our final momentum is going to be the same. If we add these together, we end up with a single line like that. That's P initial. After the collision, the momentum is going to carry on in that line. So P final equals 102 kilograms meters per second at an angle of 29.74 degrees south of east. Okay, so now using the final momentum, we can now work out the final velocity. So P final equals mass final, velocity final. So I rearrange that for VF divided by mass divided by mass. VF equals momentum final divided by mass final equals 1,209 kilogram meters per second over, well, they're hanging together, so it's going to be their combined mass now, so 70 kg plus 60 kg. So it's going to be 1,209 divided by 130 equals 9.3 meters per second. So the final velocity is going to be 9.3 meters per second that way. And so it's going to have an angle of 29.74 degrees south of east. And that's the final answer. So when you're dealing with momentum in 2 dimensions, you have to use vector mathematics to add the momentums together, because remember, momentum is a vector, so therefore the direction is important. When the direction is important, must use vector addition.